Okay, well, welcome everybody back to our second session here. In the first session, we did an overview of ZVM. And so what I'd like to cover in this session is a brief overview of single system image. We didn't really cover that in the overview. There just isn't time when you're looking at the entire product and trying to understand CP and virtual machines and so forth. So since SSI is a key part of the installation, as you're going to see, if you install VM, you can either install a non-SSI single VM system, or you can install an SSI cluster installing up to 4 members during the install process. So a bit of understanding of SSI would be helpful at this point. So looking at ZVM single system image, this feature was introduced with ZVM 6.2, and at the time it was a priced optional feature. So if you wanted to run an SSI cluster, there was an additional charge for the SSI feature. That was changed with ZVM 7.1, so there is no longer a charge for SSI. That feature is available to anybody with a ZVM license. An SSI cluster is a set of VM systems that share resources. The cluster of VM LPARs could span central electronic complexes, but they have to be within FICON CTC distance. With ZVM 7.3, it's possible to have an SSI cluster that has up to 8 ZVM systems participating. This is a change. Prior to 7.3, for example, 7.2, the maximum size of an SSI cluster was 4 members. Even with 7.3, the installation process only creates up to 4 members. So if you want to create an 8-member SSI cluster and you're just starting from scratch, you can use the install process to give you 4 members, and then you have to use the process that's identified in the publications of cloning one of those members to create members 5, 6, 7, and 8. So there's a bit of work involved in doing that. SSI clusters, as I said, allow VM systems that are participating to share resources. And in particular, it's a benefit for the ZVM system programmer because you can manage those shared resources as logically a single resource. In addition, and probably the most notable feature about single system image is the ability to move Linux virtual machines while they're executing, so non-disruptively, from one VM system in the cluster to another. And this facility is known as live guest relocation. It applies to Linux virtual machines. So in an SSI cluster, there are some common resources that are accessible from all members. There are shared DASD or shared disk for both the system and virtual machines, so virtual server data. There's common communication and common storage area network access. So I'll have a chart a little bit later on where I'll go into a bit more detail on those, because talking about that with a picture is easier than just words. All members in the SSI cluster are part of the same Inter-System Facility for Communication, ISFC collection. And the media over which the ISFC communication flows are FICON CTCs. So to have an SSI cluster, you need to have multiple ZVM systems that are participating, and those systems, the control program in those systems, are communicating over the CTCs. And you can have more than one CTC interconnecting the members in the cluster, and in fact, that's recommended. So when you IPL a ZVM system that's part of an SSI cluster, during the IPL process, it will join the cluster and it will identify itself and make sure that it can communicate with all the other members that might currently be running in the cluster to maintain the integrity of the cluster. So there's a verification and communication establishment. When you shut down a ZVM system, then it leaves the cluster. And on a clean shutdown, all of the members that are still running in the cluster realize that that member is down clean. And so the status of the cluster continues to be good at that point in time. CP is going to validate and manage all the resource and data sharing. So we'll see that there's ownership of DASD devices when we talked about system configuration, which helps CP in that process. So the benefits of an SSI cluster, it facilitates the horizontal growth of ZVM workloads, since you can look at the cluster as logically being one large VM system from the standpoint of virtual machines like Linux virtual machines. It allows you then to have work span multiple LPARs, and this is really helpful if you need more real memory to support your workload than the 4 terabytes currently supported in a single VM system would allow. It also allows you to reduce the effect of planned outages. So if you need to shut down one member in the cluster, you can move the critical workload on that member to another member that has capacity so that those critical workloads do not have an outage, even though the VM system is going down. And once that VM system member is back up and running, you can relocate those critical servers back to their home system. This has helped out somewhat in the current environment by the ability to dynamically bring in standby memory and then to dynamically remove memory from a running VM system. So that has really helped in this area. It also simplifies system management. So the shared resources in an SSI cluster are things like the directory. There's one source user directory for all of the VM systems in the cluster. So when you need to add a virtual machine to the directory, you don't have to worry about adding that definition to 4 or 8 separate VM system directories. There's just one source directory. And if you run a directory manager like Dermaint, for example, you simply issue derm commands to Dermaint to add a virtual machine or modify a virtual machine, and that's all you need to do. Dermaint handles the commands to each VM system to bring that new updated source directory online on each of the res packs for the members in the cluster. So we have a single source directory for the cluster, but the object directory is still unique for each member of the cluster, and that's because the res volume for each member in the cluster is a private volume to that cluster. So the directory cylinders are unique for each member in the cluster. That's why in an SSI environment, it's even more important than in a standalone VM system to have a directory manager. If you didn't have a directory manager, you could simply edit the single source directory to add your virtual machine, but then you'd have to run manually DirectXA on every member in the cluster to bring the changes in the source directory online to the control program in that member. There's also a single maintenance stream. So in an SSI cluster, you would install service once on one member in the cluster, and then you could potentially test it on that member. You would put it into production individually on each member. So one execution of service to get service installed, and then that service is basically available to any member in the cluster where you're linking to, in this case, main 730's minidisks. That's where the alternate service location minidisks are on. And then the put to prod process which runs separately on each member of the cluster, takes those service components and moves them out into the production runtime locations, which are typically on the res volume for that particular member. So that makes service much easier as well. And it does support the manual balancing of workload across members in the cluster. So here's the diagram that I mentioned to you, and if you've been around ZVM since 6.2, you've seen this diagram since that period in time. And it's the typical one to try to describe an SSI cluster. So as I mentioned, we have individual VM systems, and here we're showing 4 members in a cluster. And each of those members are interconnected with each other member using FICON CTCs, typically multiple FICON CTCs. And so you can see that it is a point-to-point connection. Each member has point-to-point to every other member in the cluster. Now, in terms of how many FICON CTCs, that really depends on what you're going to do, how much live guest relocation you're going to do. The minimum would be 2, and that's really for availability. What's been found over time is that probably the sweet spot in terms of getting the most out of performance is and would be the maximum is 16 CTCs that interconnect each member. And that would be 4 FICON chipids with 4 CTCs defined on each of those FICON chipids. So you need CTC connections. Now, also, there's this notion of private DASD. So there's DASD devices that are owned by the individual member of the cluster, and that would be the res volume, the private work volumes, DASD, where you might have multi-configuration virtual machines, mini disks on them. So those are DASD volumes unique to the member. And the res volume is a good example. Paging volumes are good examples as well. They're private to each member. And then you're going to have shared volumes. So CP is sharing read-write these DASD volumes, and the control programs are communicating with each other across the ISFC links to maintain data integrity on those shared DASD that are shared read-write among all the members. So here you have some particular volumes. The common volume, which contains the persistent data record PDR, where all of the control programs are writing heartbeat information, that is a shared volume. All the member spool volumes are shared read-write as well. And then if you have virtual machines that are single configuration virtual machines, for example, they can only run on one member at a time, but run on any member. Typically, the DASD for their mini disks are shared read-write as well across all members of the cluster. Then we've got these circles. The solid circle is to denote that the IP network needs to be the same for all members in the cluster. So access, if you have multiple networks, then all members have to participate in those multiple networks. So it is critical that the networking be the same, be available the same on every member in the cluster. The same is true, and that's the dashed line, for storage area networks. So while it's not possible to install ZVM on E-devices, in other words, FCP-attached SCSI disks in an SSI environment, it's possible to still have FCP-attached SCSI devices, E-devices, or even just FCP devices that are being used dedicated for Linux virtual machines. So there's no limitation there. The caveat is that the storage area network zoning, masking has to be the same across all members in the cluster. So every member has to have exactly the same access to those devices as any other member. So that's basically an SSI cluster.
Thanks for watching. If you enjoyed this video, don't forget to like and subscribe to see more videos like this one. Have a suggestion for another video topic? Feel free to leave a comment below.